In any case, this is the art of web defense, and we're going to learn how to assess the web defense of applications, whatever your web infrastructure looks like. If you're talking about a home website or an enterprise application, a lot of the tools and techniques we're going to talk about are going to be the same. So here's the obligatory introduction. My name is McKell Gomm. I go by Mick or Tyriel. And those are some of the certifications I have. I am a senior security engineer at Henry Schein Practice Solutions. We're located in American Fork. We're a Fortune 250 healthcare company. We have a lot of fun together. We've got a growing team and a couple of recs out, so if you're interested, please come by and let us know. I've got over 10 years of full-time technology experience. Started in a help desk, like many of you probably, and have over 6 years in web application security as well. By way of honorable mention, I have some of my colleagues here. David Cross, aka Lord Vader, helped me out with some of the research for this project, and so I thought I'd mention him here as well. Okay, so welcome to the dojo. Here's the agenda. The first part, and the bulk of it, is going to be going through HTTP security headers. And we'll discuss why maybe we're not using them and best practices for actually improving the defense of our web applications. The second phase is going to be on additional defensive techniques. I'll probably gloss over most of it so we can focus on the fun, more deep technical stuff. So the first question, I guess, is ninjutsu versus karate. So I'll cover that real quick. The first section is HTTP martial arts. So it's important that we know the protocol and all of the specs that will enable us to defend our web applications as well as we can. So are we talking about ninjutsu or karate? Well, I did a comparison. Ninjutsu, as you look into it, is actually focused around espionage, okay? If you want to be a ninja, it's all about being stealthy, right? It's actually more of the red team aspect. Karate is about self-defense, and so I did a comparison of the definitions of karate and HTTP. I'll let you read them there, but obviously they're very similar. Extremely popular worldwide, that applies to both, and karate is used for self-defense, and things like HTTP headers and other aspects of the protocol can be used to self-defend your web applications, okay? So, focus here is to learn proper self-defense. Just like karate, if you know the skills of HTTP, you can disable attackers, but if you don't, you may end up hurting yourself, like this guy. Thought that was a fun GIF, and I had to put it in here. Okay, so we'll cover some basics. I know you guys have been here all week, ready to wrap it up. You probably attended some application security courses. We had some good trainings, and so these things you're probably hearing for the third, fourth, fifth time. But here's some HTTP response codes. 100 level, that's hold on. Oftentimes that's just informational. Hey, you try to hit our server, here's what's going on. 200s are here you go. Typically, if you see a 200, that's the server responded back with whatever content you asked for. 300s are go away. Server saying you tried to hit something that doesn't exist or you need to be redirected somewhere else. 400s are you screwed up, meaning let's say you're trying to use a REST client like Postman, which we're gonna use in just a bit, and you put some incorrect parameters or headers in there. It's gonna tell you screwed up. And then 500s are I screwed up, meaning there's a server issue, maybe it doesn't have the content that you need. So why is that relevant? It's important that you know how your apps are behaving for attackers, okay? So you notice the title of the presentation is the art of web defense, which of course I got from Sun Tzu's book, The Art of War. And one of the main principles that he talks about is knowing your enemy. So one of the first things that you should do, which we're not really going to go into in detail today, is figuring out how your application behaves as you're finding attack vectors, trying to inject code, that sort of thing. You want to know if it's coming back and giving 500 errors if people are injecting code, because that's an easy way for web application pen testers to find vulnerabilities. So know how your apps are behaving. Next, we're going to go into HTTP methods. Okay, so we're starting to get a little bit more technical here. Here's some of the methods you can use. There are some others that are deprecated I didn't include, but in general, this one's the good and the bad methods to use. In general, post is the best one. The params are stored in the body and are encrypted. Get is the other most common one. The data is kept in the URL, so that's susceptible to modification. For obvious reasons, you don't want to be, for example, submitting login credentials using a GET request. They're color-coded, obviously, so the ones that are orange are the ones that may or may not be good depending on the use case, okay? So obviously, some of the things we're going to cover today, including HTTP security headers, they're going to depend on your tech stack and what your business needs are. And so we're not going to go into a lot of technical detail because it's going to depend on your implementation, okay? So just by way of reference, though, there are a few others here. Put, delete, patch, and options are all used for REST web services, and tells you what to do there. Put is update or replace. Delete, of course, is delete. Patch, update, modify. Options is for pre-flighting XHR requests. Okay, and that leads us to our first tool here. So we're going to go into Postman and curl. If we can have our screen work. Sorry, we did not test the screen switching back and forth, and so maybe looks like we're having problems with tools. There we go. Okay. So this is a tool called Postman, basically a REST client you can use to submit requests to servers and see what comes back. This is super useful for looking into what HTTP methods and headers and cookies are being used. So obviously this is going to be a prime tool for looking into just about anything we're going to cover today. So first thing is, you can see we've done a few requests here. You can see, let's go to our options requests. So when you hit options, as I mentioned, it's going to tell you which methods are allowed by the server. Okay. So the reason why that's important is because if you're doing recon on a web application, this will tell you what methods you can use to find vulnerabilities. Right here, you'll see there's an allow header. That tells you what methods are going to be allowed. Okay? Simple GET request, we'll unsubmit this. So these are for, we're going to stick to a few different areas. We'll hit Amazon as a tech company. We'll hit healthcare. I think we're going to use probably Aetna as our dummy. And we'll also hit financial services, because you'll see there's a distinct difference between them. So over here, this is Amazon. So as we're looking at HTTP headers, we'll get there. But what's important about Postman for this section is that when you hit this drop-down menu, it'll tell you what methods you can use to hit a web application. So as I said, get and post are very similar, except that params are usually stored in the body using a post request. Some of these are actually WebDave methods, and so they're basically deprecated unless you're working on a legacy stack and you're still using those. But I just want to show you that tool so that you know that there's an easy tool that you can use to assess that. Okay, so the other ones were curl and Cookiepedia, so I'll show you those real quick. So I've got a Kali VM. I'm assuming all of you know what Kali is and what it's used for, but basically it comes pre-built with a lot of hacking tools, right? But basically you can see here at the bottom, there's a curl command that you can use to do a lot of the same things that Postman can do, okay? It's an easier way of doing it. Obviously, if you prefer CLI over a GUI, you can use this. But basically, so again, I'm using options here. I'm hitting chase.com. You can see it responds back with an allow header and tells you the methods that you're able to get, okay? So the reason why those are important is because when we go, oops, go back here. Some of these methods you may or may not want to use. Now we'll go to the next one, which is, we cover the good and the bad. This is the ugly. Trace, head, and connect. Before were assumed to be web methods that you could use, really safe. Not so anymore. That may be new. That may be news to many of you. But if you look on the OWASP website, also here's a quick aside. You'll see these OWASP bubbles at the top right. Those are important because OWASP has a lot of guidance for some of the things I'm going to cover today. And so if you go to the OWASP website and just Google whatever it says in that bubble, then you can find the guidance they have there. So basically, you can go to that site and you can get more information on these vulnerabilities. But trace basically echoes back the data that's sent to the server. Okay, it's basically just like an echo when you send a request. The reason why that may be bad for your web application is because it can result in a cross-site tracing vulnerability. Okay, so you need to know whether or not your web application supports trace, how you can turn it off, and why it might be a bad idea. Head, also assumed to be really safe, can actually lead to potential access control bypasses. Had no idea before I started researching this, but if you want more detail, again, go to the OWASP site. It defines the actual exploit there. And connect allows the client to use a web server as a proxy. So again, unless you want one of your web servers to be used as a Tor node, then probably shouldn't be using that one. Then last of all, Dave and I came up with honey verbs. So think about it this way. Some of these methods are probably bad. These three in particular. Well, what if we actually enabled them, but we were logging and alerting every time somebody was using that method? Okay? Well, that might tell you when somebody is either scanning your application or trying to maliciously use those methods, okay? So, that's copyright Mick and Dave. Nobody can use it. Just kidding. So start with logging and alerting on some of those methods and be aware that there are vulnerabilities and issues associated with them, okay? So know what these methods do and which of them you should allow. The next tool we're going to cover, and probably the most useful we found, is called Security Headers IO. Okay, here's the site. So this is put together by a security researcher in the UK. His name is Scott Helm. Highly recommend you come here first as we start into the security header piece. So what's interesting is what this does. You can put in a URL and it basically will scan a URL and tell you how it's doing as far as security headers go. Any of you that's seen Qualys's SSL labs for you, this will look very similar. So we're going to scan Amazon real quick, see what grade they get. Just takes a few seconds here, of course. We're going to go into detail on each of these security headers, but yikes, we broke it. No, the demo gods hate me. Let's try again. Uh-oh. Amazon gets a D, everyone. Is that bad? That's kind of bad. Okay, so we're going to dive into each of these security headers and what they do and everything, but suffice it to say that this is a fantastic tool for checking out who uses what security headers, right? And which ones are most often used and which ones we need to work on, okay? So, X-frame options, that's to prevent things like clickjacking attacks. So, same origin means that only your domain is able to use your web content, okay? It also gives you some really good information on what the missing headers are and then some upcoming headers. So he's done some research on some new headers. ExpectCT is one of them. I think we go here, yep. So this is Scott Helm. He's got, a blog post basically just about every security header you could think of. So as you're going through and you want to learn more about some of these new security headers, you can go ahead and check it out there. So in any case, Amazon using strict transport security, so that basically enforces HTTPS. We'll talk a little bit more about that, but basically it prevents downgrade attacks. And using the X-frame options to make sure that nobody can basically spoof Amazon site using their content. But it also has some missing headers, okay? So we're going to cover these, but basically content security policy is basically this mind-blowing tool that nobody uses. It's an effective measure to protect your site from cross-site scripting attacks primarily, but basically it's your own security policy that enforces security at the browser level, okay? And XSS protection, again, there's specific attributes or directives for some of these security headers that we absolutely should be using. For things like content security policy, you realize when we get there, it's so deep that it would take hours just to start to get our heads around how many directives we can add with content security policy. XSS protection, that one's pretty simple. There are just a few modes to it. Typically, you're just going to want to use block. It prevents any scripts from being executed within the browser. Okay. Content type options obviously prevents sniffing for specific MIME types. You'll want to dig into that a little bit more. And then refer policy is a newer header that allows the site to control how much information the browser includes when it's redirecting to different sites. Okay. So that's one of the tools you should definitely be aware of. So we're getting here. Okay. Cool. So again, we'll cover what you should have with basic security headers. When you're trying to secure a web application, we're talking about defense here. When you have cookies, let's say, I don't know, a session cookie, you should have 2 flags on sensitive cookies every time. Okay, secure and HTTP only. What they do is HTTP only allows you to be accessing cookies only via HTTP protocol. Okay, as in not via JavaScript. Also, JavaScript is the main way that people are able to steal session cookies and that sort of thing. And so you need to have that flag on there. Secure also makes sure that those cookies can only be sent encrypted. Okay. XSS protection we covered, content type options we covered, cache control, again, just 2 directives you want to have there, no store, no cache, so you're not caching sensitive data either, okay? Then a few more X-frame options, I covered that, again, that's mainly clickjacking. Strict transport security, again, that's another security header that hardly anybody's using, but they should be. It's sometimes can be hard to implement if you have a web application that's transitioning from web services that are using HTTP versus HTTPS, but basically, again, it protects from protocol downgrades. Content type, that one's very important too because you don't want to be allowing for attackers to be sending in content types that you don't want to allow, right? If you're mainly just providing HTML, basic HTML, just only provide that content type header so they can't be rendering anything else in the user's browser, okay? So here are the advanced security headers. These are the ones you're going to want to try before you buy or test drive them. Public key pinning. So this one's, I think in my initial testing, I only saw that Facebook was using this. But basically what that does is it pins the public key when you're talking about TLS handshakes to the browser. And report only is a directive that says it's basically detect mode. Okay, we'll talk about web application firewalls in just a moment, but basically it's your detect mode for public key pinning. It's not going to block anyone yet. And then we're going to go into detail on CrossOrigin resource sharing, or CORS, and content security policy. Again, content security policy is a huge topic, but these are the actual names of the headers. Just so you know, the latter 2 header names are deprecated, so you're just going to use content security policy. But it's important to know because you may see in some legacy applications they're still using the deprecated ones. which may or may not be honored by your typical browser. Okay. So when you're implementing these, use the content security policy. All right, so this is CrossOrigin resource sharing. Basically, this is when you have two domains that are trying to share resources, but you want to make sure that you're allowing, you're basically whitelisting the resources that are being shared across domains. Okay. So the browser should be responsible and only make same origin requests, and you can use cores to integrate with other sites and use other remote resources. Basically, again, you're going to want to make sure that you're whitelisting only the sites that you're pulling resources from. Okay. It also tells the browser what HTTP verbs, again, verbs or methods, and the headers are available. The bad form of using the header is to just leave a star there, or obviously not use it at all. But access control, there's a few different headers you could actually use within cores. Again, these two, cores and content security policy, get much deeper, and there are several different headers you can use. But you've got access control, allow origin, allow headers, and allow methods. So again, this is an easy way for you. You can configure this on your typical web server or your web application firewall to be adding these headers and only allowing specific methods. For example, if you don't want to allow trace or head because of the vulnerabilities we talked about earlier, this is an easy way to put them in. You just throw in those security headers. Okay, next topic is content security policy. And OWASP has a CSP cheat sheet that goes into a lot of detail. Also, you notice there's a link right here for Mozilla. Another great thing, it's probably good to mention now, we're going to have a web defense cheat sheet that I'll tweet out after this that has a lot of this content on there. It's got the links to the OWASP cheat sheets. Also, this Firefox Mozilla link is going to be on there, and a lot of the topics we're going to cover. And so, feel free to wait for that rather than taking pictures or screenshots. So, content security policy. This can get very specific and is the deepest part of security headers, really of the talk. Basically, the server is telling the browser what it's allowed to do. You'll find that I'll go ahead and go here. Dave and I figured out a name for that: browser application firewall. Okay, so this is how you configure your BAF. Your server is basically going to tell the user's browser what it's allowed to do, what kind of code it's allowed to execute, what resources it's allowed to use, etc., etc. It can get very granular. But basically, you're defining a resource loading policy, which scripts the resource can execute, right? If you don't have much JavaScript in your web application, or you just don't want to allow any external scripts to be executed, obviously, that's easy to do with content security policy. Obviously, for your companies, as you're implementing these are the things that you need to test thoroughly before you actually implement. But again, controls where plugins can be loaded from, so things like Flash. If you don't want to allow Flash, you can just nix it entirely. Controls where images, video, and audio can be loaded from, and which domains can be loaded in frames from the protected resource, okay? Similar to X-frame options. Okay, so this is just a snapshot from the OWASP cheat sheet, but as you can see, content security policy has a bunch of different directives you can use, and each of these have different attributes underneath them too. So basically, you're going to want to, as you look into these. Unfortunately, we didn't have time to research and provide directives for each of these, and again, it's going to depend on your infrastructure and tech stack anyway. But basically, you're going to want to look into each of these different directives for content security policy as you're implementing them, but obviously this can dramatically improve the defense of your web application. Okay, so bad form, of course, for CSP is not even putting the headers in there. They're really basic CSPs that you can put in there. We've got down in the bottom section. But basically, you don't want to allow loading JavaScript from any other domain. Obviously, if you have a malicious server that's ready to be injecting JavaScript, you don't want to have that be allowed. Don't rely entirely on the XSS protection header. Again, this is another different way of protecting your web application. And don't set loose the CSP policies and think you're secure. Roll out a CSP after you've thoroughly tested. Again, we have another copyright here, BAF, that's totally ours. But yeah, the content security policy totally acts like a browser application firewall. And so that's why it's very important for us to start researching and looking into these, because a lot of times, through no mistake of our own, end users get hacked. That may be because they're just working on an old browser, right? It's not supporting the right aspects of the HTTP protocol or whatnot. But content security policy is an easy way for us to throw in security headers that allow our end users to be safer as they're browsing. So again, good form, content security policy, report only. This is another really cool thing about content security policy. It's totally like a browser application firewall, because report only is your detect mode. Okay? It's just reporting on when something is being used that you don't want to see. So JavaScript is being pulled from another domain and executed in your web application. If you put this header in, then it'll let you know. Apart from that, if you're ready to go to protect mode with content security policy, here's some of the directives you can have in there. Default sources, script sources, connect sources, and style sources. So you want to specify those and whitelist any sources you're pulling from. So covered that. CSP is a lot like a browser-based web application firewall. So make sure to do some research and look into implementing these types of security headers. Okay. Now, so here's some HTTP Easter eggs. We'll do a quick demo here real quick. I just happened to be on the Twitterverse the other day and saw that somebody had tweeted the find of some interesting web headers. This is $shaveclub.com. Again, if you don't know how to use DevTools, you right-click in a browser, hit inspect, and it'll show you. But basically, we're just going to go to network and snip some of the traffic here. If I reload this, I'll take a moment to pull all the resources, and then we're going to go up here. Okay. So this is just a more for a fun thing, but again, we're talking about HTTP headers. Do we have it here? Nope, not that one. Oops. That would be awesome if they just took it off. Let's see. Yeah. I may need to. Sorry, guys. So basically what it has here, you can see it's got a custom HTTP header here. So basically you put this into a Linux command line. It'll base64 decode this string and says, actually, I think I have it, still have it open. Yep. Here's what it decodes to. Mail a resume with the subject, yo, I'm a Jedi, to engineering.careers@shaveclub.com. Okay? So that's fun with HTTP security headers. You can put custom headers in there. Obviously, I've covered some ones that are built into the HTTP protocol that we need to start researching and implementing. But this is a fun way to drum up some new security folks. Okay, that's one of them. Another idea that we had at Henry Schein, we actually have a bug bounty program. So if you use BugCrowd, HackerOne, you have your own, whatever the case is, that's another thing you can put into your HTTP security headers. What about that? If you have a web application, but you have a bug bounty program for it, well, anybody that's trying to hack your application is going to see these web headers, right? It's one of the first things they're going to see when they do recon. So what about putting in a custom header here, which we've already done, by the way. We already have our own base64 encoded string here that points them to our bug bounty program URL. Okay, so just another idea that would be fun for HTTP headers. Okay, so that was the first section. We're going to jump into some other defensive techniques. Obviously, we can't cover everything, but these are just some basic things that I think were important to mention. Okay, using TLS. Using TLS is important, but using the best form of TLS is better, okay? One important thing to know, I'm sure any of you that work in application security know this, part of the pain of using TLS is the only way you're going to use the best forms of TLS is by having educated end users, right? They have to be on particular platforms. They can't be using Windows XP anymore. Stop it, okay? So, but in any case, here are the best practices for using TLS. First of all, you've got Kali's SSL scan, so I can show you that real quick. Do a quick demo. So built into Kali, there's also a tool called SSL scan. So I'm going to let's do chase.com. Okay? So another CLI tool, it's really cool to use. The reason why this is important, because we have Qualys SSL labs, right? But that only hits public infrastructure. What if you're trying to test and see what cipher suites you're supporting on your QA tier or something else that's internal? Well, you can use this CLI tool. Basically, it has a lot of the same information. Naturally, I prefer Qualys. It gives you, SSL Labs gives you more detail, but this will still do the trick because you can see the supported cipher suites, and it'll tell you the version of TLS it supports, which cipher suites are preferred, which means they default to this when they're doing the TLS handshake. And if you support TLS 1.0 still, for the most part, we're trying to get off of TLS 1.0. It's probably only a matter of time until there are hacks on that. But that's just one of the tools you can use. Another tidbit here for the TLS certificate, when you're doing the key exchange, the bit length of the key exchange actually matters a lot, okay? Should be using at least 2048. If you're using 1024, then you need to fix it soon. It's not sufficient. So in general, you're going to want to use elliptical curve crypto. That's what it looks like. ECDHE or ECDSA. They're used for different things, obviously. But if you're using AES, it's typically the stream cipher you're going to want to use that encrypts each message. At least 128-bit keys. The SHA digest size should be at least 256. And don't use any deprecated ciphers. So MD5 triple DES. Some of you are probably using triple DES still. You should think about getting rid of it as soon as you can. Again, here's a link for the Qualys recommended. It's on SSL Labs. That's actually a GitHub link, but it'll show you what the typical or the recommended cipher suites are. Okay. Web application firewall. So we talk about browser application firewalls, but web application firewalls are important too. Can I get a raise of hands real quick? How many of you have web application firewalls or are using it? Whoa, that's like maybe 1/4 of you. Okay. So if you have web applications though, you should have some sort of web application firewall. Why? That's an easy way for you to implement all these security headers we've been talking about today. Okay? On top of that, there's some other things you should be doing. So you should be using this stuff are the security headers, some of the basic ones we covered, XSS protection, X-frame options, that sort of thing. They also come out of the box with baseline security rules. How about that? So basically controls that are like your content security policy, they're coming out of the box. So typically they're built in regular expressions that are doing data validation for you on any inputs. So if you have a robust web application, there's any forms or injection points in there in your web application, WAFs provide you with baseline security rules for that sort of thing. Also, they can be your TLS terminator. Again, an easy way for you to be configuring TLS, pulling out deprecated ciphers, that sort of thing. So those are the basic things you should be doing with WAFs. But do you do these? There are also advanced security rules. You can be writing your own. If you've ever heard of mod security, you can customize your own WAF rule sets. Okay? Well, with any other WAF, you can make your own custom rule sets too. Okay? It's easy. It's as easy as using regex. Okay? Custom headers. Again, we covered being able to put in custom headers that say, hey, if you want a job, go to this URL. If you're trying to hack us, please go to our bug bounty program, that sort of thing. You could also remove your web or app server response details. So big problem that's out there is that as you're doing recon on any web application, some web applications give you a lot of detail about the infrastructure. Hey, we're using Apache Tomcat version blah, blah, blah. Is that a good idea? Nope. Should be stripping that information out. WAFs can do that pretty easily. Another thing we discovered just recently is that session entropy can matter quite a bit too. You look at these two graphs, the computed session randomness for a web application was not very good. You can see it's clustered there right in the middle. Okay? It'd be easy to basically predict session keys if you're not using proper entropy. Okay? Web application firewalls obviously can handle that, and optimal session randomness makes it completely random. Okay. So here's a question that nearly everybody who's ever dealt with a web application firewall has asked: how much do they actually cover? Well, OWASP did a study. Again, it's all out here on OWASP. Of coverage of known security vulnerability types, okay? There's 32 of them in this list, and basically web application firewalls cover, well, 26 of 32 of them. That's over 80% of your typical web application vulnerabilities. Can be virtually patched with a web application firewall, okay? So things like, these are just some examples that I pulled out. Obviously the list is bigger, but you can use WAFs for cookie protection, again, adding secure and HTTP only attributes to all of your sensitive cookies. Session writing, so CSRF, again, you can be adding your own CSRF tokens in there. For any type of code injection or data validation, obviously WAFs come out of the box with rules for that sort of thing. The only two things on the list that WAFs don't really have coverage for are application logic, okay? So if you're talking about enforcing password complexity in an application or access control for an application, those are things you have to build into your application that WAFs really struggle with, okay? Here's some detail on character encoding. So basically the way encoding comes into place is when we're talking about code injection. Being able to properly encode any of your outputs is important. There are a lot of different character sets and encodings, but basically you should be using UTF-8 unless you have a good reason not to. It's the most widely used way to represent characters. It's safe for web pages. All the browsers are built to be able to handle UTF-8. Safe for databases also. And it uses dual byte characters for international character sets, which again is fine. Modern browsers react well to using UTF-8. Sanitizing input for safety. So the reason why this is important is for mainly cross-site scripting. So you'll see there's an OWASP bubble there to go check that out. But basically all input should be sanitized before adding it to the document object model or the DOM, okay? So there are a couple ways of doing that. Obviously you can have data validation being done by a WAF. You can also do that at a code level, but it needs to be done. Basically, what you want to do is escape input if it's going to be used in JavaScript on the page. Okay. So how do you escape input? You can put a backslash in front of specific special characters. Okay. So for specific ones that are used in either SQL or JavaScript, apostrophe, quote, double quotes, parentheses, that sort of thing. Also, the encode function is deprecated, so use encode URI. That method is the one that's recommended, okay? Encoding your output. So again, in cross-site scripting, whether you're talking about a reflected cross-site scripting vulnerability or a stored one that's in a database and may be executed in a user's browser later, you're going to want to encode the output before it gets rendered in the browser, okay? HTML encode any data being presented in HTML. The reason why you do that, again, is so that you can avoid any JavaScripts from being executed. Basically, that turns script into ampersand LT, which is less than. And the HTML coding will basically render any scripts that are injected useless. Okay? The HTML encoding can also be in hex form, so again, that's just another tidbit. If you have any problems implementing HTML encoding, you can try using that. Encoding for URLs. So there's a different type of encoding you use for URLs. It's called URL or percent encoding, called percent encoding because obviously there are percents in there for specific characters. So for example, one character that'll break a URL is a space. So that actually gets encoded to %20. So you're going to want to be encoding anything that's input into a URL using percent encoding. Okay, cross-site scripting can be executed within the URL too, so that's why that's important. Base64 in URLs should be used with care too. So when your base64 encodes something, it can actually produce some breaking characters too. You've got a few there. For URLs, you can use save base64. Basically, make sure that there aren't any of those self-breaking characters in there. So again, base64 can give you a false sense of security. Doesn't work well every time, so make sure to use percent encoding wherever you can. All right, so this is another one of my soapbox moments. When you're dealing with web application security or anything in security, guys, I don't care if you're a network engineer or you're working strictly in AppSec, any vulnerability we're talking about in technology is because of code. All vulnerabilities, guys. That's why it's so important for us to start training developers on security. They don't get enough training. They just don't. And the reason why that's important is because of this graph. 70% of vulnerabilities can be prevented before coding ever starts. How does that happen? Well, you need to have a secure SDLC, which we'll cover next. But basically, your potential for vulnerabilities should be going down as you deploy. Reason for that is in every phase of the SDLC, you should have specific security tasks that are going into it, okay? You should be doing design reviews and threat modeling. The reason why this graph is important too is because the first rule of application security is to assume that all users are malicious, okay? That's why we sanitize any inputs that end users are putting in. We don't want our applications to break in any way or get hacked and be releasing sensitive data, okay? Another thing this does as we go into, I'll go to the next slide, that's our secure SDLC. There's a ton on here. I know, but all of it is important, okay? So we're working with developers in application security, specifically for web application security. There are a lot of different things we can do to train developers, make sure they're coding things right, make sure that we have proper defenses in place. I'll actually tell you that WAF config and updates is over in maintenance and response. That actually should be closer to the beginning, okay? As you're building security in, that's when we should be talking about these security headers and things that we've talked about today. But I basically just wanted to put this up here and show you that in every phase, there's specific security tasks that need to be done, okay? Again, design review, threat modeling, then you get to testing later when you're in beta, when you're in a beta phase, when you're preparing to deploy, that sort of thing. And if you have any questions on that, we can talk about some of these in just a moment. Again, we've covered a lot of OWASP concepts, and they have a lot of guidance and directions on these, and so I basically summarized the different OWASP pages you can go to. Testing for HTTP methods, they've got a page on that shows you how to. Useful HTTP headers, again, that's the main one we've covered today, which ones you should put in. Some of them are very simpler, others, like content security policy, are much more in depth. But there are specific cheat sheets you can use for those. Use of web application firewalls, again, there's a page for that. And then it's also got stuff for things like single sign-on, and ISAPI's a data validation library. Okay? So I had to end with my favorite ninja of all. This is Donatello. Love that in the new movies he's the team geek. So he's the hacker on the team. It's perfect. But basically, here's a summary. Know the protocol. So HTTP, there are a lot of security headers that are built in you probably hadn't even heard of. But we should be starting to research each of those and be implementing them. Okay. We are going to be providing you with a web defense cheat sheet. I mentioned earlier, I'll tweet that out so you can download that. I'll just put it on Dropbox, and all of you can download it. It'll have all of the web security headers we should be researching. And for specific ones that are simpler to implement, like XSS protection, we'll give you the exact directives that you need to put into the security headers. Okay. Again, secure SDLC. There are a lot more that goes into defending web applications. It starts with every single one of your developers. Make sure they know best coding practices and how they can defend web applications. Use your WAFs to the max. For a lot of you don't even have a web application firewalls, apparently. But for those of you that do already, make sure you're using them as much as you can. And then you turn to OWASP for a lot of guidance on some of these topics. So that's about all I had. We have a few minutes, so I thought we'd open up real quick to Q&A. If you have any questions on specific security headers or on things like the SDLC we've got up here. Do you have any questions? No, it's too early. We just want to get out of here. We're ending early today. Yeah, go. The average website is not using very many. So we covered Amazon, and I'll show you Chase.com though. Financial services just blows everybody else out of the water. It's kind of embarrassing. They get an A. Chase gets an A. So financial services, they're doing pretty good. But they're like cutting edge security. They've got most of the most important security headers in there. SAINTCON, we can try that one. Now, with the understanding that all these are landing pages, right? They're not really robust web applications, but SAINTCON gets an A. Yeah. Cool. So SAINTCON and financial services are doing well. Everybody else stinks. Okay. Any other questions? Oh, cool. Thanks for your time, guys.